Let's talk about SN2 nucleophiles. Now, the nucleophile is the most distinctive feature for an SN2 reaction, and you might wonder, well, how is it distinctive? Well, once we see all the four reactions, then you'll have a better picture of what makes a nucleophile distinctive rather than when you don't have the nucleophile. But this is the key driving force for a reaction. So, what are the best nucleophiles for an SN2? There are three of them. One is azide. Now, azide is N3 minus. But of course, N3 minus doesn't float around by itself. It needs a salt. And almost always a salt is sodium. So sodium azide. But N3 is a nucleophile. If you want to know how this looks, it's kind of a weird anion. It's 3 nitrogens in a row. Fantastic nucleophile. If people use sodium azide, they are intending to do an SN2. There's no question about it. What's another great nucleophile, which is a slam dunk for an SN2? Cyanide. CN minus is fantastic. And you might say, cyanide, isn't that poisonous? Well, it can be. However, it's also chemically a fantastic nucleophile. So this is the Lewis structure of cyanide. It's an incredible carbon nucleophile. And the anion is on the carbon, not the nitrogen. So do not draw CN minus, okay? The negative goes on the carbon side. What's another great nucleophile? This one's less commonly encountered, but any sulfide. Sulfides have a sulfur that's negative attached to some R group, and that R group, could be methyl, ethyl, you name it. These are all three fantastic nucleophiles. When you see these, you think SN2, because that's the reason that chemists use them. Okay, so what are the good nucleophiles? There are a lot of nucleophiles that get used in SN2 that aren't necessarily the best, but still are often used for SN2. Okay, hydroxide is one. Now, when I say the word base, you probably think in your mind hydroxide. As it turns out, bases aren't always so good in SN2 reactions, but hydroxide certainly can be used in SN2 reactions. Note that almost all the good nucleophiles may also be basic. And we'll see that that's a problem later and is going to lead us to the E2 reaction. But the fact is these reagents I'm going to list can be nucleophiles in the SN2. Now, just as sulfide is a pretty good nucleophile, a sulfur minus attached to an R, an O minus attached to an R can be a pretty good nucleophile, and these are called alkoxides. R could be methyl, ethyl, what have you. Okay, what else? Acetylides. You'll probably encounter these more in second semester organic. But deprotonated alkynes, these are called acetylides. And people use these for SN2 reactions. We'll probably see an example or two of those. What else? This is going to look really strange. But carbanions next to a carbonyl. These are called enolates. We'll see these much more later in the semester rather than now. However, for completeness, I want to mention the fact that enolates are good SN2 nucleophiles, where you have this carbanion, it's carbon with a lone pair. What else? Amines can do SN2 reactions. We won't see much of this. But nitrogens, sp3 hybridized nitrogens, can do SN2 reactions. So there are really great nucleophiles, and these are the top three, and these are slam dunk. They will always do an SN2. If it's possible, they'll do it. The good nucleophiles often are a little bit basic, and they will try to do an SN2 reaction, but they can also involve an E2. I tell you what, I want to throw in two more. bromide and iodide we will see sometimes do SN2 reactions. They're kind of weakly nucleophilic, but under the right conditions they work pretty well, and I just put that in there for completeness because we will see them pop up their heads later. So this is a list of all the common nucleophiles we will encounter. When you see these, you need to keep your eyes open for SN2 reactions.